The problem is a slider crank mechanism. As shown in the figure 1.4, figure will be given in the problem. The force applied to the piston is 1000 Newton or 1 kilonewton. When the crank is at 120 degree, angle is given 120 degree from IDC. Determine the input torque. Torque T2 we have to calculate here. And the distance given are 200 mm OA and AB is 900 millimeter. And the force applied on the piston is 1000 Newton. The construction, first we have to construct this complete slider crank mechanism with selecting a scale. Here the scale selected is 1:10. All the lengths will be converted into 1:10. That is nothing but 200 divided by 10, 900 divided by 10. So we will construct this first and then we will draw the pre-body diagrams. First draw an horizontal line. A horizontal line you have to draw at the beginning. So we'll draw a horizontal line. And then we'll mark a point, call it as O point. From this you have to take 120 degree. From that point you have to take 120 degree. So we'll take from this point 120 degree. So 120 degree I have marked on this. And then we'll join with the thin line first. And then this angle is 120 degree. And then convert the scale. 200 length is given, so divided by 1:10 scale. I have taken 1:10. So 200 divided by 10 is 20. You can divide it by divider, or you can take the length from here. On 120 degree you can take the length, or you can divide it. So 20 mm will get there, or you can divide it with the help of divider, 20 millimeter. So we'll keep at this point and we'll divide the scale. Then another length is given 900, that is divided by 10, it is now 90 millimeter. So keeping at this point, cut the horizontal line by 90 millimeter, that is original scale is 900 millimeter. Now wherever it intersect, just join these 2 points. The intersection point. So you will get B point. So this is O, this is A, this is B. Now just in general draw this piston. There is no length for this. And this piston is a 4th link, and this is the base link 1 on both the side, and this link is called as 3rd link. This is 2nd link. Here the torque T2 will be there. That torque we have to calculate T2. Now all the construction is over now, and the force acting here horizontally at this place with the direction F is equal to 1000 Newton. So this is a problem given. After completing the construction, after completing the construction, you have to draw the free body diagrams. For this, you need a roller scale to construct a free body diagram with the same length you have to transfer. Now we'll draw the free body diagrams. Keep this parallel to this. No, parallel to this only. So now we'll draw the same length here with 20 millimeter, or you can cut later by drawing the length. This is 10. Parallel to this, draw a line of 20 millimeter. You can draw it, then you can cut later if you want, or you can draw with a 20 millimeter same length. Now keep parallel to this, keep a roller scale parallel to third link. You can draw just by moving parallel to this third link. Keep it clearly, slowly move. So you can move it slowly. We'll draw here. Then we'll cut it by same length. Now take the divider. Take 90 millimeter from the divider, because the length AB is 90 mm. Now we'll keep one point and we'll cut it. So this point is B, this point is A, here this point is O, this point is A, torque T2 is there, and here third link, this is second link. Now this piston will draw here first. At this point, this is fourth link and B point. Now the force acting at the contact is always normal, or you can draw perpendicular to this point. It should be 90 degree. And then another force always perpendicular to this, and another force is given, that is 90 degree. You can take 90 degree. So for this, draw the 90 degree line, because both are perpendicular to each other. Just for showing, you have to draw this 90 degree. This is the force F acting 1 kN, and another force is parallel to this. Another force acting is parallel to this. Move slowly. And draw at this point. Or you can take this and move roller scale, draw from this point. Now after drawing the free body diagram, you have to show the forces acting on it. Now at this point, this second link, at this point the force acting is 1 on 2. First link acting on second link. And this point, third link is acting on second link. So you have 3, 2. Now when you consider third link, at B point, fourth link is acting on third link. At A point, second link is acting on third link. Now if you consider this, the force F1 is acting on 4. 1 is acting on 4. Now this is the F force acting third on fourth. Third link on fourth link. This is how you have to write the forces acting on each link, each point of the link. Then after this, known force is this, and this is the 3 pores member, and one force is known. In third link both the forces are unknown. In second link also both the forces are unknown. So only known link is here, that is 1 kilonewton. So convert this scale into 200 centimeter. So 200 Newton equal to 1 centimeter. So that is nothing but 1000 Newton equal to how much? 5 centimeter. 200 Newton equal to 1 means 1000 Newton equal to 5 centimeter. Now draw parallel to this F, or you can take it as horizontal line of 5 or 50 millimeter. So we'll take from here. Parallel to F, that is nothing but horizontal force you have to draw 5 centimeter. So this force is known and the direction is also given. So depending upon direction, right behind O at the front A, and this is F is the force 1 k Newton and 5 centimeter. Now another two forces are known, one is perpendicular, another is F34 parallel to third link. Now this perpendicular force you can draw from O or A. You can draw from O or A. This F34 also you can draw from O or A. One you have to transfer from A, one you have to transfer from O, so that it will form a polygon. Now we'll draw a perpendicular. This is 90 degree always. You can take with the protractor 90 degree for accuracy of the results. So 90 degree line, then extend that line from A point, extend it, and then parallel to this force is called as F14. Parallel to this you have to transfer from another place, that is from O. From A I have transferred F14, from O you can transfer parallel to third link from O. So it will intersect one point. So this point is called as B. And direction, one direction known means other direction will be in a cyclic order. Now this force is called as F14, this force is called as F34. Now you can measure the distance. You can measure the distance. You can measure the distance. This is 16. From 16 I am taking distance. It is at 11. Then you can measure this also. It is around 10 mm. So F34 is equal to AB into scale. So AB you got pi, around 5.1 will get, multiplied by scale. Scale is, we have taken 200 Newton. So 5.1 into 200 Newton, 1020 you will get, and this distance you will get 10 millimeter. So you can calculate F14 is equal to 10 into 200. Sorry, 1.0, that is 1 centimeter, you take here centimeter, so it is equal to 200 Newton. This is 5.1 centimeter multiplied by 200 Newton. So 200 Newton you will get F14. Now we'll remove this part. Once again you have to draw parallel to this line. Once again you have to draw parallel to this force. So exactly parallel I am drawing here, 20 millimeter. parallel to second link I have drawn. So 20 mm is there. Now after drawing that, once again you have to draw parallel to this force. Because you have to show the forces acting on this line, and the cut it by 90 millimeter. The distance is 90. This point is called as B, this point is called as A. Now F34 is equal to 43. So 34 line of action direction is known. F43 is always equal and opposite in direction. F43 is equal and opposite to F23. So F23 is equivalent to F43. So F43 is in upward direction, F23 should be downward. This forces you have to show for third link. Then draw the parallel line for the second link. Parallel to second link you have to draw. That should be 20 millimeter. Length should be same. And then the forces acting here, T2 will be acting. Force T2. Still we don't know the direction. Now we will transfer this force. We'll transfer this force at this point. At this point, and also at this point. Should be parallel. And the force acting at this is F32. F32 is equal and opposite to F23. It is downward, hence the direction is upward. F32 is equal and opposite to F12 again. So 32 is upward, F12 is downward. Hence this is the couple acting, this side and this side. The couple acting is counterclockwise, hence the torque acting is clockwise. And the perpendicular distance you have to measure, the perpendicular distance between 12 and 32. So that is called as H. You will get 15 millimeter. That is multiplied by original scale. That is 1:10 you have to convert. 15 into 10 is 150. For this only polygon, you have to convert this Newton scale. For this, you have to convert it into original scale and then multiplied by any of the forces. F32 and F12 are equal and opposite to F34. 34 you have calculated 1020. So you will get 1,53,000 Newton mm clockwise.